what if analysis, the data table, and it says what is your row input cell. We leave that blank. The column input cell we're going to put in as cell C7, which is 5.5%, and that's the value that's going to be changing. And we say OK, and we should get the result as it appears on the screen. If you do get a message which says there's some error, it is probably because when you highlighted the table, you highlighted also the titles, and that is not permitted. If you remember, a data table only has the text in there, which are the numbers rather. We have now finished step 2. Okay, we are up to step 3. Let's type in the heading amortization table, which again I typed in already, and let's continue to enter the other headings as well. So the beginning balance, the ending balance, and the interest paid, etc., etc., etc. Okay? After we do that, the beginning balance, which you see over here, is nothing more than the amount in cell C6. What is cell C6? Let's take a look. That's what we put in, since that's the amount. Let's go back down. Now the ending balance, this is one that we have not covered yet. It's another financial function, and it stands for the present value. Let's just do a quick explanation of it for the time being. The present value function returns the present value for a situation one has a series of fixed payments made in each month. For example, the present value function demonstrates how much one owes at the end of each year. And the syntax of the formula is present value, as we see over here. In fact, why don't we just, for a moment, put in equals present value to see that. And the syntax is then present value, typically would be the monthly rate, the total number of payments, and it'll be the payment for each period. So if we follow that information, we should be able to understand why we got what we got in our cell. I'll leave that up to you. Now, in the next cell, paid on principal is just going to be the difference between the beginning and the end balance. And the interest paid, we can figure that out as well from the above formula. Alright, now we're going to copy down all the information to the following cells. Okay, now we're not going to discuss the values at this point because we have one other step to do first, and that is to copy down the value based on the function also down to 15. And when we do that, we now see, hopefully, that the result should make sense. I have just done it for 15 periods, but in reality, we would do it for more. And slight changes here. Instead of having month, I should have year, etc., etc. In any event, we do see that the beginning balance, which started at $235,000, is now down to $73,000 after a period of 15 years. And the ending balance, we see what has happened with that as well. And we see how much we have paid on interest and how much we have paid on principal. And as we said, the amount of principal continues to go up, and the amount of interest continues to go down. And you'll see at the end it should match exactly what we did at the beginning of the module. We're going to look at one last example which will give us the basic idea of creating a amortization table. This schedule will indicate payments on a car that we looked at a little bit earlier. Let's assume that $20,000 is borrowed at 7%, and let's reduce the number of our loan period to 3 years rather than 4 years. So we're going to create an amortization table over here. We're going to enter the beginning value, that is the date we are going to start paying it off. And I already copied down, but you can copy down for the next 36 months, and we can use autofill to do that. Then in cell E1 we're going to enter B3. B3 is the amount that we have borrowed. Now we have something new. In cell E2 we're entering what's called the future value. The future value of an investment based on periodic constant payments and a constant interest rate is provided. Let's take a look first at the general formula. It equals future value, and those are the parameters: the rate, period, the amount of time periods, and the payment. So again, we have the rate is the rate per period, NPR is the total number of payment periods, PMT is the payment made each period, and PV is the present value, which is how much one owes at the end of each period. NPER is equal to 1 instead of 36, since it is a 1-month period for each payment. Given this, let's put the cursor on E2 and let's drag down, and we should see our result, which shows us by July 1st, 2014, we have paid off our loan, and we have now 0 remaining. But we see how the loan has dropped as we go down from 2011 to 2014. As you see, we can apply this to many examples. It's a matter of working out the amortization table and understanding the formulas, both the present value, the future value, and seeing the calculations. Most likely we're not going to have to create these. These have been done for us, but at least we can see how the calculations work, and we can hopefully make use of them and plug in our own values as well.